Welcome back to our next episode on off-highway vehicle design. I'm Lance from Motive Power, and today we're going to bounce happily along and talk about suspensions. Now, suspensions are a huge topic, and you really can't talk about them in their isolation. It is part of the holistic design of the whole vehicle. So today is just a bit of a taster. We can introduce you to a variety of tools and components that are possibly suitable for your design. We're going to cover more about how to approach the design than the design itself. And we're only going to talk about wheeled vehicles. We did touch on crawler vehicle suspensions earlier. It's another whole subject in its own right. As usual, we'll start with some terminology. You've probably heard some of these terms, and we'll use them a little bit through this discussion today. But we'll start with unsprung mass. That's essentially the bit that's resting on the road below the springs. The sprung mass is what's above the springs. And yes, there are components like the springs that are generally could be considered part of either. Normally what's done is to split the mass of the suspension components in half and assign half to the sprung mass, half to the unsprung mass. You may also have heard of the term called roll center. This is the geometric center about which the vehicle will roll, and it's generally determined for each axle set in its own right. In a four-wheel vehicle, there would be a roll center for the front axle and a roll center for the rear axle. They would be different if the suspensions were different. It determines a roll axis for the whole vehicle. Now, when a wheel hits a bump, which is basically what we've got suspension for, the wheel is supposed to move up. Now, that's called bump or bounce or compression. When it hits a hollow and it moves down, that's called a rebound, jounce, or extension. I prefer to use bump and rebound. Bounce and jounce sounds a bit too corny. We'll try and stick to those terms today. We've left a suspension discussion until after we've talked about axles and steering. But the reality is that the axles, steering, suspension, the wheels are all part of one big stew of components you're going to have to sort out together. Makes a little more sense if we're talking about suspension now, but really it needs to be in the mix all the way through. Now, suspensions are very complicated. Lots of Laplace transforms and integration and stuff I haven't done for 40 years since university. There are textbooks, and I'll show you some. They're few and far between, but if you've got eagle eyes over a career, you can collect them. And they're great background, but they all suffer from one particular problem. they're all based upon race car suspensions. That's where the theory was originally developed. In the 50s, 60s and 70s, indeed, this one's part written by Michael Costin, the Cos in Cosworth. That's the era we're talking about. And while I'm going to talk about a whole array of things today, I'm going to ask that you consider this sort of theory and then consider whether it's relevant to your off-highway vehicle. I'll explain that a little more as we go through. So this is one of my favourite photos. Off-road racing, fairly serious, and it's a great suspension example. Except it shows you the limitations of suspension. And they are significant. Obviously, these wheels are off the ground. That one might be on the ground. But the importance of suspension, it's not comfort. It's not really handling. It's to keep the wheels on the ground. That is what it is for. So in this photo, the suspension has failed to do its job. You could define the job differently, but for the purpose of this discussion, I'm going to say it hasn't done its job. The reason is, while these wheels are in the air, you can't steer, brake, or most importantly for a race car, accelerate. And there are obvious safety issues as well. So the primary role of suspension is to keep the wheels on the ground. Now, you will have seen the frog, my friend the frog, from earlier videos. This is an example that suspension isn't always required. The centre two axles are not suspended. The fourth axle and the first axle are. It's a relatively slow speed, relatively heavy vehicle designed for off-highway with big tyres, big baggy tyres. So suspension isn't needed in the middle two axles. Not needed, might be preferable, but it works fine without it. One of the big parts of all of that theory in those textbooks I showed you is about minimising unsprung weight, unsprung mass, I should say. I'm going to suggest that that is almost irrelevant for this sort of discussion. Off-highway vehicles are generally very large. Ride quality is not a high priority. You're more concerned about traction and carrying load. Getting hung up over unsprung mass is counterproductive. If you can keep it low, that's great, but don't focus too much on it. So what I'm really saying to you is learn the theory, but temper its application to make sure it suits your particular application. So generally, suspensions involve some combination of springs, masses, and dampers. And we're going to quickly run through the sorts of springs you might be able to use in your designs. Number one, back to the frog again, are these black things, the tyres, because that's what they are on these two axles. They're the springs. And that might be fine for working in soft conditions off-highway. And I'll give you another example of where it's fine. Here's one that we all recognise, Bobcats. No suspension, don't need it. It's a short wheelbase machine operating in soft ground typically, so suspension is not a priority. But you may have trouble at speed as a result of lack of damping. If we're going to talk about real springs, the simplest one is a leaf. And here's a typical leaf spring installation. These things get a bad rap when compared with coil springs. The reality is a well done leaf spring can almost equal a fairly lousy coil spring. design. Generally speaking, leaf springs are not well designed. They're very simple, therefore cheap. If you're going to use them on heavy weights, you end up with a lot of leaves, and that makes them very stiff and therefore not very good at going over bumps. But done right, for lighter loads, they can be a very simple, good, cheap solution. So next is the good old coil spring. And, they're used all over the place. Simple too, but the problem is they take up a lot of vertical space. That makes it a packaging issue. And it also requires other links to restrain the axle. Leaf springs restrain the axle, coil springs don't. So it's a much more complicated arrangement. This is actually a poor example of an automotive spring in that it's a constant rate. A better example would be one with a variable rate, so that it was soft up to a point and then got progressively harder. One that you don't see on cars very often, unless I think you've got an old VW. These are torsion bars. They're a long bar with splines on each end, and they're twisted. Usually there's an arm off one end that takes the vertical load from the wheels and imparts a torque onto the bar. And the bar resists that torque, hence torsion bars. They are really great for low floor heights in vehicles. They're often used in armoured fighting vehicles for that reason. It is also possible to nest them, to have a solid bar inside a hollow bar, and you get extra deflection because you've now got twice the length of bar working. That can also give you some level of progressive response, because as you move from one bar onto the other, you can change the rate. Next one up is airbags, and I'm sure you've heard of them. So this is a cross section here of a rolling diaphragm airbag. This is the type you would see on highway, on the back of a semi-trailer, for example. And as this part moves upwards, the bag rolls around, hence rolling diaphragm. The other type is a convoluted bag. It's more suited to extreme conditions in that there's no rubbing between the bag. Rolling diaphragms can abrade and leave you with a puncture. Both work quite well, but do leave you with the problem of what to do when you have either an air leak, a pierced bag, a broken hose, and there's always the challenge of, do you put height leveling valves on them and use a little bit too much air? They're usually on highway used just as assist springs, but off highway can be used as the complete spring. If you want to use rubber but not an airbag, how about a marshmallow? These are Firestone marshmallows. Essentially, they're a cylindrical rubber unit with a hole through them. And they work really well as springs. They also have a fair bit of internal damping and reduces the requirement for other shock absorbers. Rubber springs can also be used in struts. Here's some Tech Pack units designed for haul trucks. And you'll see there's an array of rubber pads inside a steel strut. So that's a pretty good soft riding, progressive spring arrangement that doesn't require air or maintenance. If you like Mini Minors or old Citroens, you'll know all about gas over oil suspensions, and they're certainly usable in off-highway vehicles. This is a photo of a Caterpillar haul truck front suspension, and there's the gas over oil strut. The gas provides the springing, the oil provides the damping, and they're used extensively in haul trucks because they can carry heavy loads. Now you can do that as a specific unit, or you can just take a hydraulic cylinder, add some valving and an accumulator and achieve the same result. So, now we know what springs are available, we need to look at what sort of mechanism we can incorporate them into. So, we're sort of talking about definitions and terminologies here again, but bear with me. First one I want to talk about is this. This is a walking beam. On each side of a bogie, there's a pivoted beam. That pivot runs across the vehicle, the beams run along. And essentially, it allows each wheel to move up and down. Because there's a beam here, and it's a pivoted beam, if you hit a 100mm bump here, this point here will only go up 50mm. So it smooths the ride. It's also very straightforward, quite basic arrangement. There are some complications around how it's joined to the axle. You'll see this one's got a torque rod, but that's a walking beam, quite commonly used even in triremes. Unfortunately, I couldn't find a good photo of an equalizing beam. It gets confused with walking beams, but an equalizing beam runs across the vehicle. And this is a Dana Spicer axle, and I believe this is the pivot for it. It's a tractor axle. So this axle can pivot around this point. This wheel can go up and down, same as this one, seesaw arrangement. Now that would be an equalizing beam arrangement. A lot of axles do this with a bearing down here around the center of the diff housing. It's the same effect. It's probably a little better than this. This arrangement requires the axle to move laterally as the suspension works. And on many aircraft towing tractors, I've run a beam from the mounting pad on one side to the mounting pad on the other and put the pivot pin in that beam, effectively creating this arrangement, but with an axle that wasn't available with a complete equalizing beam pivot already in it. Ideal for big, heavy loads moving at slow speeds. Now, neither of these types I've just talked about, equalizing beams and walking beams, have springs. So they don't actually absorb energy from the road. Moving on to things that were originally done for on-highway, we'll talk about leading and trailing arms. Variety of ways it can be done, A-frames and independent arms and all sorts of things. If this is a front axle, these two members would be leading arms. If this was a rear axle, these two would be trailing arms. If you look under a Range Rover or Land Cruiser, you'll probably find it has leading arms and trailing arms. And there are other links required as well, but that's the basic arrangement. And popularized by smaller Japanese cars, a McPherson strut, a coil spring wrapped around a shock absorber. Interestingly, this spring is actually shown as progressive, so that's great. I would suggest this is for lighter vehicles only. Simple, easy, but not really suited to heavy loads. Now, multi-link suspensions are a bit of a combination of the previous. Essentially, there's links all over the place. And this one looks like an independent suspension. If it was a live axle, it'd probably have torque arms and so forth as well. And since we're talking about off-highway vehicles, I'd be remiss if I didn't give you another sort of example. We're using a CAT 631, 637 example. This is a scraper. The suspension on this scraper is actually in the hitch between the front half and the back half. Let's go down and have a look at it. There we go. It's essentially using an oil over hydraulic spring again, like the haul trucks we looked at earlier, in the mechanism, in this actual linkage in here. So it's suspension, but it's not related to the wheels. So that's a quick run through some suspension types. Next, I want to do the same for axle types. And you'll note that it's sometimes difficult to differentiate between the two because they're so integrated. Alright, here's a very simple live axle, differential, tubes, brakes and hubs. So live axle, not independent. The pros for it, it's simple, it's easy, it's low maintenance. The bad is maybe as a worse ride on light vehicles, and in things like fighting vehicles it requires a higher floor because the diff has got to be at the height of the axle. It can't be lower than the center of the wheels. Then we have independent suspension. This is a complete integrated axle, but it does have independent suspension built into it. You'll see the upper and lower control arms and the shock absorber. Again, it's probably better ride on lighter vehicles, although this particular model I doubt is for really light vehicles. Unfortunately, good independent systems tend to get compared to bad live axle systems, and it blurs the comparison. This sort of thing allows the floor of an AFV, for example, to be lower than the wheel center. The bad part of it is there's lots of joints, and a lot of those joints are vulnerable to impact, particularly if there's a steering arm run across the vehicle at the front. So my message to you today is to look at all of these different types. Think about how they can be brought together in a correct combination for your design. Go find a good textbook, understand the theory, the concepts of suspension design, and then suck out of that theory the bits that are relevant to your application. It's always good to have low unsprung mass, but it's bad to go chasing really low unsprung mass just for the sake of doing so. In terms of geometry, try and always make things progressive so that under normal conditions it's a nice soft ride, and as things get worse the ride gets harder to cope. Leaf springs are fine if they're done right. I must emphasize that. And if we talk about articulated loaders, because I've used that as an example on many previous videos, the suspension is often only on the non-load carrying side. So it would typically be on the rear axle rather than the front, so that the load can't roll the vehicle. Sort of issues with suspensions, you're all familiar with them. Vibrations, corrugations, natural frequencies, shock absorbers that maybe aren't quite up to coping with those natural frequencies and vibrations. You may not have had the dubious benefit of encountering porpoising. Yeah, that's when a vehicle starts to do that, even at very slow speeds. I've had 20-25 ton aircraft towing tractors just leap into the air at 15 kilometers an hour for no apparent reason. In later life I found it wasn't just me. Happens to Caterpillar too. This beast, which doesn't seem to want to fit on the camera, is a Caterpillar Goa. It's a Vietnam era logistics transporter, and it was a fantastic amphibious vehicle for use in monsoonal Vietnam. But on highway it started to do this, and you don't see them around anymore. After Vietnam they were trashed. The reason is the only suspension in that is a roll suspension between the front and rear halves. There's no springs other than the tyres. Tyres are pretty good springs, but they have no damping. So once they get energized, they're going to start doing this, and away it goes. I've experienced it. It was a big surprise. One of the things that came out of that was I found there was actually no standards for the roundness of tyres. So you're starting with an egg that's a good spring but a poor damper, and hoping it doesn't overly excite your vehicle. So just be careful you don't end up porpoising. So now I want to get into some nitty-gritty details. When you are designing the suspension, you're going to design the bolted joints to attach the axles to that suspension. If you're working with vehicles with very high tractive efforts, you'll probably find the bolt holes in the axles are not sufficiently large enough for the bolt size that you need to hold that axle in place. I've had to open up axle holes or axle bolt holes on a number of axles in my career, and it's something you need to be aware of. Don't just blindly accept the hole size you're given. In addition, the bolted joint is likely to be under a lot of shear from braking and maybe from traction, depending on your suspension. It may be necessary to put in dowel pins or circular dowels around the bolt holes, just to take the shear load off the bolts. There are limitations as to how big a bolt you can put in. Obviously, if you drill the hole out too big, you'll pierce the axle housing itself and the oil will get out. Resist the temptation just to go up in grade. At a, if I talk metric, 8.8 is fine, 12.5 or whatever it is fine. Higher than that, your bolts get very brittle. They're strong but brittle, and you may find you have axle bolt failures if you use them. Now remember that a bolted joint is carrying much more than the load that's applied to it, because that bolted joint is preloaded. You've actually done that nut up to the point where you're getting sufficient stretch preload on that bolt, leaving enough capability in the bolt to carry the working load. You need to be very careful how you determine that, and very careful about how you torque those bolts. Do not ever let anybody lubricate the bolts. I've had trouble where people have put silver grease, commonly called silver shit, thinking, oh, this will make it easier to tighten the bolts up, and it will. It'll make it easier to get the bolts out too, but it'll over torque the bolts and you're going to run a risk of failing a bolt in service. If you're using Loctite or some other sort of thread locker, my understanding is they don't impact the torques for the bolts. In fact, the bolt torques are usually quoted in an as produced, i.e. lightly oiled condition. Not dry, but certainly not greased. So if you're going to torque these bolts up, make sure they're in their standard as delivered, as produced condition of lightly oiled. Do not apply any more lubrication to them, and then torque them up. Be careful of what that torque limit is, and make sure you're torquing critical bolts that a torque limiter or some sort of torque wrench is used. I've had many fitters in my time tell me that they know how tight the bolt is, and that's a complete fallacy. They don't. So that's a quick run through suspension and some of the traps. Please remember that comfort is a secondary concern. Yes, we all like to be comfortable, but I'll take a little bit of discomfort over trying to unbog an off-highway vehicle. Don't let ambitions to have a sexy machine lead you into areas that aren't going to work for you. I know independent suspension is everybody's best idea of what should be on a vehicle. Fantastic. Even the military's been sucked in. But it isn't always. And you're going to face more cost and more complexity and more damages and more maintenance as a result of going that way. There are times it's a good solution, but like everything in engineering, it's a compromise. My preference is to pick the simplest damn thing you can do and get away with. It'll save you money, time, stress, and complaints. So work out a system you can live with. Make sure that you can maintain it, support it, the parts are available and all the rest of it. And then with all of that settled, confidently move on to do the rest of the design. See you next time.